All right, guys, you guys are listening to this because I am not feeling great. So that's why I'm not at work. But here is the start of the chain rule. So 3.6 says the chain rule. Let's start with the rule itself. We are going to do the derivative. So the chain rule is used for when we are trying to find the derivative of a function that seems super crazy, right? So in this case, it's a composition of two functions. So when you have a composition of two functions, we first do the derivative of the outer. So f is the outer function. Then multiply to the derivative of the inner function, okay? Just like that. Now, if you look at example number 1, it says find the derivative, so d over dx for the equation y equals sine of 7 minus 5x. So this is your inner right here. That's a composition, right? So this is your inner and this is your outer. Because usually, guys, sine is just with the sine of x, but right now it says sine of 7 minus 5x. So it's clearly 7 minus 5x is a different function. Now, sometimes it's easier if you let the inner be a different function, like u. So this is called u substitution. So we can let u be the inner, which is 7 minus 5x, okay? Then the derivative of that is u prime equals negative 5. And that means we can rewrite this as y equals sine of u. So the derivative is really, the derivative of sine is cosine of u times the inner, which is u prime. Well, we can just put u back in. So y prime equals cosine u is 7 minus 5x times u prime, which is negative 5, so times negative 5. We don't normally put the constant at the end, so we're just going to move it to the front. So just like this. And that's your final answer. Let's box that up. Now, look at number 2, a very similar question. We can use u substitution again, just to make it easier for you guys. So you can let u be the inside, so the inner function, which is 2x minus x to the third. So u prime is going to be 2 minus 3x squared. Then just rewrite this, y equals tangent of u. Well, we do know the derivative of tangent is going to be secant square of u, but u, it's an inner function, so we do have to multiply by the derivative of the inner. So now let's plug it all back. So y prime equals secant square, u was this right here, 2x minus x to the third, then times u square is 2 minus 3x squared. Now we can put that in the front so that way that's not to be confused. 2 minus 3x squared times secant square of the quantity 2x minus x to the third. That's really as far as we can go, and then we're just gonna highlight that or box that up. Now it says here power chain rule. Oh my, sorry, I don't feel like 100% right now. So power chain rule, so it looks like we have a quotient rule first. That means a power chain rule is just using the chain rule, but there's more steps to this, just having one inner component. So the quotient rule says y prime equals u prime times v minus v prime times u all over 1 plus cosine of x squared. Oops, you know what? Let me just write v squared. All right. So let's whoa, that is a fat one. Let's minimize that pen really quickly. So u be the numerator, which is sine of x. Okay. So that means u prime is going to be cosine of x. V is going to be the bottom, 1 plus cosine of x. So v prime is going to be, well, the derivative of 1 is 0. The derivative of cosine is negative sine of x. So let's put it together. U prime is going to be cosine of x times v, which is 1 plus cosine of x minus v prime is negative sine of x times u, which is sine of x, all over 1 plus cosine of x quantity square. So next we would probably distribute. Okay, so cosine of x times 1 is cosine of x. Cosine of x times cosine of x is going to be cosine square of x. Two negatives to make it a positive, so that's going to be sine square of x all over 1 plus cosine of x quantity square. Okay, so do you guys remember cosine square of x and a sine square of x, that's going to be 1. So we now have cosine of x plus 1 all over 1 plus cosine of x squared. Now we can reduce 1 at the top because these two are similar. So we can reduce, and that means on the top we now have 1, on the bottom which is 1 plus cosine of x, and that is as far as we can go. That's the derivative of sine of x over 1 plus cosine of x.